between greatest common factors and least common multiples. We want to answer this for a number of different reasons, one of which is that they actually have different purposes and usefulnesses when we talk about mathematics, especially in relation to fractions and other algebraic concepts as well. So introducing this and getting a good handle on it at a young age, and this course, this video is geared after people who have already some type of basis and background and understanding of this mathematics. And this is just to reiterate and clean up some loose ends on all that stuff. But the idea is that these two concepts collectively are very useful later on in a student's understanding of mathematics in, say, an algebra class. So building those understandings early is really quite useful and important. So when we looked at greatest common factors, one of the things we want to understand is first and foremost, what does it mean for it to be a factor versus what does it mean for it to be a multiple? So let's look at that real quick. Okay, so when we say a common factor, well, let's think about this in terms of, say, two numbers. Because if it's a common factor, that's implying that there's multiple things we're looking at. So let's say we have 15 and 12, right? And we want the greatest common factor of those two things. What is that value? Well, one of the things we can do is we can think about what the factors of these two numbers are. The factors here are fairly limited. 15 would be 3 and 5. 12, I'm going to write this one maybe a little funny, is going to be 3 times 2 times 2. You'd be tempted to write this as 3 times 4, but when we write greatest common factors, a lot of times we want to write this in terms of their prime factors as opposed to just any given number. It makes it a lot simpler going forward as we work through other examples. But one of the things we notice here when we do this is that 3 and 3 is in both places, so the greatest common factor between these two things is 3, meaning that the largest number that will divide into both of them is 3. I'll say that again. The largest number that both of these numbers are divisible by is 3. Okay? So the 5 doesn't work for the 12, and 2 doesn't work for 15, let alone 2 times 2, which is 4, doesn't work for 15. So when we talk about greatest common factor, we're saying what do both of these numbers have in them that can be divided out. In this case, it would be 3. When we talk about least common multiple, let's go back and let's talk about, we could use 15 and 12 again, right? So it's least common multiple. We've got 15 and 12. Now, least common multiple means what can I multiply by and get the same number? So 15, and this one's going to be rather extensive here. So I'm going to say 15 times 2 gives me 30. I'm going to say 12 times 2 gives me 24. That's close, but it's not the same, right? So this one's smaller, so I'm going to go ahead and do 12 times 3, which gives me 36. And over here, now this one's smaller, so 15 times 3 gives me 45, right? So this one's smaller, so let's go back to it. 12 times 4 gives us 48. This point, some of the people may be wondering, like, what are we trying to do here? We're just going to write down a bunch of numbers? It's like, yeah, we're writing down is all the multiples of 15, all the multiples of 12, meaning I'm doing 15 times 2, 15 times 3, where the multiples of 15 are 30, 45, and we're going to keep going. The multiples of 12 are 24, 36, and 48 so far. Multiples means these numbers that we're getting when we multiply the original values by something. So when we say least common multiple, we need at least 2 of them. Normally we do it in pairs. And we're going to keep going until we find one that's the same multiple. So we do the next one. 15 times 4, which gives us 60. 12 times 5, which gives us 60. Right? So now we have found the least common multiple between 15 and 12, which is 60. Meaning, what's the smallest number I can get using 12 or 15 to get there? Not 12 times 15. We could do that. 12 times 15 would give us a multiple, but it's not necessarily the smallest one, right? So 12 times 12 is 144, and then we got to add 3 more 12s in there to get it to 15 times 12, right? That's definitely larger than 60. What we want is the smallest number that exists, that when we do 15 times something and 12 times something else, possibly, we get the same number. So here we're doing 15 times 4 gives us 60, 12 times 5 gives us 60. So 60 is the smallest value that we can get using 15 or 12 where they overlap. It's common between the two of them. compare that to greatest common factor. Greatest common factors, we're looking, so we divide 15 and 12. What's the greatest number, the largest number that they both get divided by, right? In this case, it's 3. Now, in some cases, let's just say we have greatest common factor of 18 and, let's see here, what else would work here? Maybe we don't want to do 18. Maybe we want to do, let's do 21 and 10. Okay? 21 and 10. Well, the factors of 21 are 3 and 7. The factors of 10 are 2 and 5. Those are all prime numbers. I can't reduce any of them any further. Which means the greatest common factor of 21 and 10 is 1. Which means these two are what we call relatively prime. Okay? Meaning the only factor they have in common is 1. They're not prime numbers themselves. Prime number means that it's not divisible by anything other than 1. In this case, the only number that they are both divisible by is 1. So that makes them relatively prime, meaning there's nothing they share in common with each other. We don't really ever have that situation over here, except, like if we were to take 21 and 10, well, how far do we have to multiply out in order to get something so that they lap over? Like, in this case, would the least common multiple of 21 and 10 be 210? Well, where 210 come from? 10 times 21. Is that the smallest value? Well, you can actually run that out. 21 times 2, 21 times 3, and keep going until and do the same thing with 10, until you have the overlap between those. Now, this is the thing. It should kind of point out fairly quickly, is that 10 times anything is going to put a 0 in that one spot. 21 times anything, except, a factor of 10, is going to put that number in the one spot. So we do 21 times 3. Well, there's a 3 in the one spot. 21 times 4, there's a 1 in the one spot. 21 times 5, there's a 1 in the one spot. We're going to keep doing that until we get to 10. There's never going to be a 0 in the one spot until we get to 10. So the fact that they are relatively prime, because the greatest common factor is 1, also tells us about the least common multiple, meaning we're going to have to multiply these things times each other in order to get the least common multiple, which is just them multiplied by each other. Okay, so these are special cases as opposed to just generalized cases. I hope this was useful, and keep doing math.